and welcome to yet another lecture on chemical engineering thermodynamics. I am Professor Arvind Prasad. Today we will learn something very interesting. We will learn that for an arbitrary process, how do you calculate the change in internal energy and the change in enthalpy? Also, how do we calculate the heat and work? Now, at the outset, I would like to tell you that pressure, volume, and temperature, they are state variables. Since they determine the state of fluid. Well, the pressure and the temperature, we all know, will decide whether a water is liquid or it is a vapor or it's a two-phase mixture. So they define the state of the fluid and therefore they are known as the state variables. Now, the process or the arbitrary process is 1 to 2 and it is shown in red. It is neither a constant pressure process nor a constant volume process. However, we can reach from state 1 to state 2 by two independent processes, which is 1 3, which is a constant pressure process, and 3 2, which is a constant volume process. Now, let us calculate the change in internal energy for process 1 3 and process 3 2. 1 3 is a constant pressure process. For a closed system, the first law can be written as du is equal to dq minus p dv. Now, process 1 3 is a constant pressure process. Therefore, we get this term on the LHS and we write du plus p dv is equal to dq. Now, since the pressure is constant, we can write it as du plus dpv is equal to dq, or we can write dh is equal to dq. Therefore, the heat absorbed in this process 1 and 3 is equal to Cp into dt. Therefore, the change in enthalpy for process 1 3 is equal to Cp into T3 minus T1. Now, let us write this as equation number 1. Now, the change in internal energy for process 1 3 is going to be equal to the change in enthalpy for process 1 3 minus PV for 1 3, since enthalpy is defined as U plus PV. Therefore, we can write this as Cp T3 minus T1, and we can also write this as minus delta P into V for an ideal gas is nothing but RT. And yes, I need to mention here N is taken as 1 mole or unit. So we can drop N. And therefore, the change in internal energy for process 1 3 is going to be equal to Cp T3 minus T1 minus R T3 minus T1. Or we have collecting the light terms, or the internal energy change for process 1, 3 is nothing but Cv into T3 minus T1. Since Cp minus R is nothing but Cv for an ideal gas. Now for the process 2, 3. We write the first law, du is equal to dq minus p dv. Since it's a constant volume process, minus p dv is 0. And therefore we get integrating delta u to 3 is equal to q is equal to Cv into T2 minus T3. Let's write this as equation number 4. Now the delta H for process 2, 3 is equal to delta U for the process 2, 3 plus delta PV for the process 2 to 3. We can write this as Cv into T2 minus T3. I would like to make a small correction here. It is process 3 to 2. We are going from 3 to 2. So this is 3 to 2, and therefore this is 3 to 2, and this is 3 to 2. And we can write that as plus PV is equal to RT 3 to 2. Therefore, we get delta 3 to 2 is equal to collecting the light terms Cv plus R T2 minus T3. Well, this can be written as R T2 minus T3, and Cv plus R is nothing but Cp for an ideal gas. So we have delta H 3 to 2 is this. Now, if we add delta 1 to 2, 1 to 3 to delta 3 to 2, we get Cv T3 minus T1 plus Cv T2 minus T3, which is equal to Cv T2 minus T1. Now, this is nothing but the change in internal energy from process 1 to 2. Since we took an independent path and we added the internal energies and it has come to Cv into T2 minus T1, we can say that whatever path we take from 1 to 2, the change in internal energy will be the same. And if the change in internal energy will be the same, we can say that internal energy is nothing but an state variable. A similar logic can be applied to the enthalpy, which is nothing but Cp T3 minus T1 plus Cp T2 minus T3. And we get this as Cp T2 minus T1, which can be written as nothing but the enthalpy change from 1 to 2. Therefore, the change in enthalpy and the change in internal energy are nothing but they are independent of the path which we take. But heat and work are never independent of the path we take. So, for an arbitrary process, we cannot calculate Q or W. We can definitely say that for this entire process, Q plus W will be equal to delta U. We cannot independently find Q and W because it is not a regular process, that is a constant volume process or a constant pressure process or an adiabatic process or an isothermal process. It's an arbitrary process. The path which it follows cannot mathematically be written. Therefore, it is impossible to calculate the integrals for Q and W. But we can definitely say that the sum of heat and the work will be equal to delta 1 2. So this was all about calculating the change in internal energy, the change in enthalpy, the heat and the work for an arbitrary process. Hope you enjoyed the video and understood how do we do calculations on an arbitrary process. Keep watching for more such interesting videos. Have a great day. Bye.